Hello again, everybody. Hope you're doing well. So first off, I apologize. I wanted to do this for a while. Actually, wanted to go over your tests in class, but we've been so busy and it's hard to find time to go over it. And I know a lot of people, you know, they may not be as interested as others. So I did want to give you an opportunity to look at the test questions and the answers. That way, if you have any questions, you can please feel free to look back through your submissions. That way, if you have any questions, you can let me know. So anyway, I'm just going to go straight through them, give you the most widely accepted answer, the most widely given answer that was correct. And but if you have any questions, just let me know. But here we go. All right. So the first question on the rock test, and I got to go way back to think about that one. But for the rock test, these were analogies. Gabbro is to granite as scoria is to pumice. Gabbro is mafic, granite is felsic. Scoria is mafic, it's also extrusive. Pumice is the best answer there. There's others as well, but pumice is the best one because it's extrusive and felsic. Number two, extrusive is to obsidian as intrusive is to, best answer there, probably granite. I was really looking to see that you knew that obsidian was also felsic, but the best answer there is granite. Sand is to sandstone as clay is to shale. So everybody got that one. And then number four, marine organisms is to limestone as peat is to coal. Remember, peat is decaying organic matter, compresses, heats up, it makes coal. All right. So the question number 5 was asking about why marble would be a preferred carving material for sculptors. So there are two main reasons why marble is preferred over other metamorphic rocks like slate. Well, first off, it's non-foliated. Marble is non-foliated, so you can curve it into nice round shapes more easily than foliated rocks, which tend to break along lines. Remember, foliated means leafy. Also, it's metamorphic, so very strong, very durable. All right, number 6, I asked you to list the 3 other systems of earth science. In column 2, I wanted you to match sedimentary rocks based on those systems. In the 3rd column, I wanted you to give me an actual example. And in the 4th column, describe how that rock was created. So geosphere was already in the question, so we leave those out. We need the other 3 systems, starting with the hydrosphere. The best answer of how the hydrosphere can help create a rock is through a chemical rock like halite, where the water is evaporated, leaves the mineral behind. Gypsum was also another good answer there. Biosphere, best example of how the biosphere can create a rock is, of course, organic rocks like coal or limestone, where once living things are compressed into a rock. And then the last one there, atmosphere. Probably the best way to answer that one was through a clastic rock, which is made from particles of other rock. So the movement of wind can create abrasion, which eventually causes that sediment to pile up and solidify into a rock. The atmosphere and hydrosphere ones, you could kind of switch around a little bit. But again, the best answer for hydrosphere was a chemical rock. All right, number 7 is probably one of my all-time favorite test questions. Imagine 3 desserts. One is fudge, second is chocolate chip cookie, and third is a granola bar. Yeah, I know, granola bar, not necessarily a dessert, more breakfast, but anyway, compare them and tell me why you assigned them either metamorphic, igneous, or sedimentary. So most like a metamorphic rock, the number 1 answer was a chocolate chip cookie. And the reason why is because the chocolate chip cookie was heated so that the ingredients change into a new form. Also becomes harder. Most like a sedimentary rock, most people chose their granola bar because the ingredients are pressed and cemented together, I think with honey. And then most like an igneous rock, most people chose the fudge because it's melted completely and then cooled into something new. Number 10. This was a tough one. I know a lot of people didn't do very well on this question, but describe how minerals can form in each type of rock and provide an example of the mineral that would be created in each type. So For this one, I wanted you to tell me basically how a pure mineral form could be created in each type of rock. All right, so let's start with sedimentary. Example of how a pure mineral form could be formed in sedimentary rock is through evaporation. So water is evaporated, leaving behind a pure mineral precipitate, for example, halite, rock salt, or selenite. Remember the crystal cave. The next one, metamorphic. One answer here, porphyroblasts. Intense heat and pressure can cause pure mineral forms to develop inside of some metamorphic rocks. The example that we looked at in class was garnetiferous schist. It's a metamorphic rock with pure mineral garnets. And then the last one, igneous, it's actually just slow cooling of magma. When magma cools very slowly, it allows the minerals to align itself into nice pretty crystals, like in granite. When you turn it, it's nice and sparkly. Each one of those colors represents one mineral. So that's a pure mineral form. Also, geodes. Geodes are basically lava that's cooled very, very, very slowly. And so the silica that's in there aligns itself into quartz crystals. All right, so questions 11 and 12. This is the checklist to be scored, and it's based on dynamic earth unit and the historical geology unit. For the full 5 points was a response with overarching generalizations and multiple specific examples using language of the discipline. So how can understanding the characteristics of sedimentary rocks and conditions in which they form help inform our upcoming unit on historical geology, the study of the conditions in earth systems throughout time? So my example for this was chemical sedimentary rocks can tell us about the condition of the hydrosphere and the atmosphere, because they show us where water used to be and possibly where water was evaporated. This also shows if there's climate change, large periods of increase in temperature, which could have caused the evaporation. Organic sedimentary rocks can tell us about the life forms that were there. So for example, coquina and limestone show us where sea level rose and fell by looking at the remains of marine life as well. They can show us the type of environment based on, what types of organisms are found in that rock. So for example, coal would be a forest, limestone would be shallow ocean. Clastic sedimentary rocks like breccia and sandstone can show us how water and wind moved that sediment around. If they tumbled, clasts, remember if it tumbles more, then there's more erosion, so the clasts are rounder, that kind of thing. And the layers of sedimentary rock can also tell us something about wind speed. For question 12, it was about how metamorphic and igneous rocks could help us on our upcoming dynamic earth unit. Our understanding of metamorphic and igneous rocks can help us inform us about our dynamic earth because of how these rocks are created. For example, plate tectonics, regional metamorphism, as things are being pushed apart or pushed together, that can create a lot of heat and pressure over a large region, which can create things like gneiss. An example in Virginia is the Piedmont region, and how we know that continental collision with part of Africa helped create the metamorphic rocks that we find in the Piedmont. Then we have igneous rocks. Igneous rocks tell us about volcanism. If it has large crystals, and we know that the volcanism was contained within the earth, cooled very, very slowly, and made things like granite. If they erupted onto the surface and they cooled very quickly, we know about the mineral consistency of that magma or lava, and that it erupted either explosively or quietly, depending on what it is. Take the Blue Ridge region, lots of magma contained within the crust in creating those intrusive igneous rocks. All right, the last one was just, I think it was the last question, last set of questions, was just matching characteristics of Virginia's provinces. And that's pretty much it. So the first one, number 13, the oldest, highest elevation igneous metamorphic rocks is Blue Ridge. The province that contains mostly clay, pebble-sized rocks. Marine fossils is the coastal plain. Rolling hills, slate, metamorphic igneous rocks, and uranium ore is Piedmont. Appalachian Plateau, of course, is coal, elevated flat lying sedimentary rocks. And then Valley and ridge would be limestone, sandstone, folded and faulted. Oh, number 18, forgot metamorphic math. All right. Sandstone plus heat and pressure, quartzite. Limestone, heat and pressure, marble. Shale, heat and pressure, slate. Slate, heat and pressure, schist. Bituminous coal, heat and pressure is anthracite or anthracitic coal. And then granite, heat and pressure. Nice. All right. Number 19, consider how sedimentary rocks change due to heat and pressure in the kiln of the earth as they become metamorphic. Also consider the metaphor about metamorphosis. Oops, sorry, too far. About the metamorphosis of rocks like a caterpillar turning into a butterfly. Which aspects of sedimentary rocks change, which stay similar when they become metamorphic? So some of the things that could possibly change as a rock becomes metamorphic. It could change its shape, of course, heat and pressure, squeezing it, moving it around. It could change its texture. It could become more shiny, like in the case of schists. It changes the porosity. So if you take a sedimentary rock and turn it into a metamorphic rock, it's less porous. It changes density because you're squeezing that rock down into a smaller space with that pressure. You're also changing its density and size. Some of the things that stay the same as you go from sedimentary to metamorphic, still the same stuff. So the chemical composition can remain the same and the color can remain the same. There are others as well, but those were, again, the primary answers. All right, hypothesis format, independent variable, dependent variable for each one of these. Most of you did very well with that. So the first one is create a plausible hypothesis that relates to the size of igneous mineral grains and cooling rate. So what we're changing or manipulating, the independent variable is the cooling rate. The dependent variable is the size of the mineral grains. And so you could phrase this one of two ways. It really didn't matter. If the cooling rate is slower, then the mineral grains will be larger. Or if the cooling rate is faster, then the mineral grains will be smaller. The next one relates to the shape of pebbles and clastic rocks based on their travel distance before lithifying. So if it traveled, what we're changing, the independent variable is the distance that it traveled. The dependent variable based on the distance traveled would be the shape or the roundness of the pebble. So hypothesis, if the pebble traveled a long distance or the distance traveled before lithification increases, then the shape will be rounder. And then of course, vice versa. If the distance traveled before lithification decreases, then the pebbles will be sharper or not as round. All right. This is the last one I think I remember. All right, consider the rock types, sedimentary, igneous, metamorphic. Identify a rock energy resource associated with each type of rock in the region in Virginia this resource can be found. Use a different resource for each category. And then a pro and con. All right, so let's start with sedimentary. We primarily, of course, find that in the Appalachian Plateau. Coal, we would typically find in the Appalachian Plateau. That's our energy resource. Pro, of course, it's very cheap, lots of it. Con, carbon emissions, and mining is pretty dangerous. For metamorphic rocks, the best answer there was the Piedmont, and specifically uranium, which is contained in a lot of rocks in the Piedmont. There's actually a uranium mine in the Piedmont, but it was shut down in the 80s. Pro, of course, is it's abundant energy with nuclear energy and uranium, but of course, it's very hazardous and we've got nuclear waste. Igneous one, the best answer here was geothermal energy in the Blue Ridge or the Valley and Ridge regions. The pro, of course, here is that it's renewable, but the con, we don't have much of that energy resource available. There's only a few very, very small contained areas where we have enough geothermal energy to do anything with here in Virginia. It's also very expensive to build. Okay, so I think that's it. Again, these were the top answers. If you have any questions about the grading or why I graded something the way that I did, please send me a message to let me know. We only have a few more, we only have a little bit of time before the end of the quarter. So if you're going to request that I take a look at one of these questions, please do so as soon as possible. I'll have another video for the historical geology. Thank you.